Hello, everyone. I'm Oliver. I hope everyone can hear me. I'm Oliver Gar, manager at SolisFAST, and I'm happy to welcome you all today to today's webinar, where we will talk about our newly launched product, SolisFAST one-step RT-PCR Kit with UNG, which is combining cDNA synthesis and endpoint PCR into a convenient one-step workflow. We will first talk a bit about what is RT-PCR or reverse transcription PCR, where is it useful, what are some of the benefits of this technique when comparing to RT-qPCR, for example, and then we will look at what is SolisFAST solution for this workflow. I'm sure you will find it interesting and useful. If you have any questions, my colleague Eva Maria can answer these as they come up in the chat. So feel free to ask some questions. And of course, I will take some time at the end as well to discuss any that were left without attention. So I think everyone can see my screen. But first, before we dive into today's topic, I will take a few moments to briefly introduce SolisFAST for those who are not familiar with us. SolisFAST is a biotechnology company located in Estonia with nearly 30 years of experience in the biotechnology sector. We develop and manufacture high-quality molecular biology reagents with a focus on reagents for PCR and related technologies. We have partners all over the world from a variety of different sectors, ranging from molecular diagnostics to basic research, who have come to love our catalog and many of our custom solutions as well. We have what makes us unique is that the core of SolisFAST, of course, are the enzymes. But at the core of our enzymes lies our unique and patented technology, the stability tag. It's a special polypeptide sequence that is genetically incorporated into our enzymes. And this stability tag stabilizes the enzyme and the conformation of it, enhancing significantly its resistance to temperature, meaning that in liquid form, our enzymes and master mixes are room temperature stable for a minimum of 1 month and up to 6 months for certain master mixes. The inclusion of the stability tag does not impair enzyme or protein function, and we have tested it on a variety of different enzymes, such as, and also different proteins. Few examples are polymerases, nucleases, reverse transcriptases, proteins such as ribonuclease inhibitors, LIF, different growth factors. This is a big benefit and enables us to offer simplified handling and logistics both to us and to our clients, and enable reaction setup without any ice. Additionally, it allows us to ship all of our products in an environmentally friendly manner without the use of any dry ice or bulky styrofoam boxes. The reagents are sent either in cardboard boxes or simple padded envelopes all over the world, enabling unique uses for our products and enzymes. So, going back to today's topic, we have a new product that is used to perform one-step reverse transcription PCR or RT-PCR. So let's briefly look at the technique and what it is, how it compares to some other options. In short, it is a reverse transcription followed by endpoint PCR, all performed in a single tube or one step. Hence why it's called one-step RT-PCR. In many ways, it's similar to RT-qPCR, for which we already have a few products in our portfolio. In both cases, you use RNA as template and perform the cDNA synthesis followed by PCR. However, the analysis methods and how you detect the result is different. RT-PCR is analyzed using endpoint analysis techniques, most commonly, for example, gel electrophoresis, whereas RT-qPCR uses specific qPCR machines and fluorescence for detection. It is also good to make another point about nomenclature. RT-PCR is sometimes referred to as real-time PCR. That translates to qPCR or quantitative PCR. Real-time and quantitative PCR are the same thing. For us, when we use the term qPCR, that's when we refer to quantitative PCR. And using the term RT-PCR refers to reverse transcription PCR. So the product that we're talking about here today. I will expand a bit more about the difference between the two, the RT and RT-qPCR, the next slide. But first, let's think about how this, why would you choose RT-PCR compared to RT-qPCR, and where it can be useful. The main use cases for this product, this one-step RT-PCR, are in detecting RNA viruses, for example, and often in settings demanding a simpler workflow. It is simpler and cheaper compared to RT-qPCR and can achieve similar results, similar sensitivity in most cases. When you do not have the expertise, equipment, or resources to train personnel, this technique can deliver similar results. So it is used in areas like applied testing, where the people doing the analysis might not be trained molecular biologists. For example, if you're an independent veterinary lab, you might not have the resources to perform qPCR or RT-qPCR, but you might have the capabilities of doing simple PCR. And this RT-PCR is basically what it is. You use the same kind of primers as in regular PCR. It's just you also have the cDNA synthesis beforehand. Similarly, in certain regions, regular PCR might still be favored for very similar reasons. And at the end of the day, it has similar sensitivity, and you can identify pathogens in the same fashion as in quantitative PCR. In many ways, RT-qPCR is a competing technique to RT-PCR. Sorry, RT-PCR is a competing technique to RT-qPCR. And the main differences come from how you analyze it. Reverse transcription PCR uses endpoint analysis. It doesn't always have to be shell electrophoresis, but that is a common technique. Whereas RT-qPCR uses fluorescence, either probes or a fluorescent dye to get the readout. And it comes with additional requirements in some ways and planning. It means that the assay design is a bit more complicated. You have to also just think about probes, for example, especially when you're doing multiplex reactions in RT-qPCR. Whereas just running a gel can be, it also, yeah. So when it comes to analysis as well, it's the same thing. For RT-qPCR, you need to understand how it works and what it shows, and it might be unfamiliar for some people, whereas just running a gel and seeing if a band is present can be a lot easier. And it's also that it might require someone with more experience to avoid some of the mistakes in setting up the experiment and analyzing it. Similarly, troubleshooting RT-qPCR can be more complicated than regular PCR. The main difference, as I already said, comes from the fact that one technique is quantitative. It gives a quantitative measure of how much target is present in a sample, whereas RT-PCR gives you a qualitative or semi-quantitative result. You can tell that there's probably more sample present here than in here, but you can't tell exactly how much. In reality, both techniques are quite sensitive or similar sensitivity. And oftentimes you're not even interested in the quantitative result, rather just yes or no answer, especially when trying to determine if a pathogen is present, if any viral RNA is present, for example. And in addition to simplicity, RT-PCR is also cheaper when you take into account the cost of reagents and you add the cost of probes, for example, which can be quite costly for RT-qPCR. And then also take into account the fact that RT-qPCR requires a capital investment, a relatively big one for qPCR machines that can be around 50,000 euros, for example, whereas a regular PCR machine can be 10,000 euros, for example, or less. So that is already quite a big difference, and many labs might not be able to afford this more expensive equipment. Time-wise, they're about equal, and when it comes to going from the sample to results and analyzing it. And overall, I guess, yeah, how is it used is, I guess RT-qPCR is considered to be slightly more reliable and accurate in some ways, and for that reason, people are willing to invest the resources. So RT-qPCR is very commonly used in human diagnostics, for example, whereas RT-PCR is not that popular in human diagnostics. Then again, regular PCR and I guess RT-PCR, either in two-step or one-step workflows, is still used quite a lot in applied testing, where some of the requirements might be less strict, and they might require a more cost-effective solution, and analysis might not always be performed by a trained molecular biologist. So they might require easier ways of doing this. Overall, the takeaway is that RT-PCR is as sensitive as RT-qPCR, and it's simple to perform. But in some cases, you might still favor RT-qPCR if you want the full reliability of that technique. Another distinction to make is that today we're talking about one-step RT-PCR. That means both the cDNA synthesis and PCR happen in the same tube, in one reaction, so to speak, or in one step. This can significantly streamline the workflow, reducing the steps required when you compare it to a two-step format, which in turn makes it more reliable as there's less room for any mistakes during pipetting or setting the reaction up, and reducing the variation between the reactions. It also reduces the overall hands-on steps that you have to do, and again, it can save a lot of time. Of course, there are cases where two-step workflows are favored. With one sample, in a one-step reaction, you can only target a certain amount of genes if you need to multiplex it. And you're using gene-specific primers, so you're not capturing the whole RNA. In two-step workflows, you can convert all of the RNA in the sample into cDNA, and then you can use that cDNA to divide it up into different fractions, and you can look at multiple genes, like 10, 15, 20 genes from the same sample, but it's more time-consuming. However, if you're working with the same targets all the time, like identifying an RNA virus, for example, one-step workflow can offer a lot of benefits in that regard. So next, I think now is a good time to introduce what SolisFAST has been working on for some time now. Our solution for a one-step RT-PCR reaction, the new SolisFAST one-step RT-PCR kit with UNG. It comes in a kit format with two variants. And one variant is the regular one, and another version is ready to load, which means it has inert loading dyes included with it in the mixture. The loading dyes do not influence the reaction, but it means that after the reaction, you can directly load it onto the gel. again further reducing the steps, for example, in the overall workflow. Yeah. So when we look at this kit, this product, it actually consists of 5 enzymes in one kit and places into a new product category, as you can see here from the overview of our portfolio. It consists of exceptionally fast and inhibitor tolerant SolisFAST DNA polymerase, a combination of our BioScript and SolisScript reverse transcriptases, our verbal RNase inhibitor to avoid any RNA degradation, and Selene uracil DNA glycosylase to remove carryover contamination. So let's now look at some of the interesting features that it can offer, some of the benefits, and also looking at comparing to some other solutions currently on the market. The first thing is that it has a relatively simple one-step work protocol, offering streamlined workflow, reduced fraction-to-fraction variation, and in general, it can help significantly save time and reduce errors. It also has we also offer it as a ready-to-load variant, as I mentioned before. You can directly load the samples onto the gel. It makes it, again, very convenient to go from just mix all the components together, take it out the reaction, put it on a gel, minimal steps, minimal hands-on steps that you have to perform. Additionally, we have the stability tag technology incorporated into all of the enzymes in this product. This enables convenient handling, shipping at ambient temperatures, and you can set up the reaction without ice. Although maybe for RNA work, it might be best to keep the RNA still on the ice and doing that step on ice. But you don't have to worry about, I don't know, maybe accidentally leaving the reagents out. Nothing will happen to it. So it's, again, another benefit. I would say the biggest benefit with this new product that we have is that it is really fast, also when compared to what is currently available on the market. When we look at the total reaction times of some other kits, of some other RT-PCR kits from various suppliers, here is a demonstration, a graphic using the fastest cycling protocols that they have on their data sheets compared to our SolisFAST option for RT-PCR. And based on this, we can say that this is currently the fastest kit on the market to do RT-PCR, enabling under 1 hour overall reaction times. Difference comes when we look at the protocol, we can see where the difference comes. It comes from the speed of our enzymes. Both the RT enzymes and the DNA polymerase are very quick. Instead of 30 or 60 minutes spent doing the reverse transcription, 5 minutes is enough for the combination of our BioScript and SolisScript. Similarly, time is saved in the extension and annealing phases due to our exceptionally fast SolisFAST DNA polymerase. Overall, making this is a very quick kit, especially when also combined with the one-step workflow. In addition, SolisFAST one-step RT-PCR Kit with UNG shows exceptional sensitivity down to 0.1 picograms of total RNA in a reaction. And we have another exciting addition, which is our novel RT-PCR enhancer AmpliBoost that significantly enhances the performance and sensitivity with some difficult templates, some cheesy-rich templates, or this secondary structures, but also it can help improve overall sensitivity in regular, not GC-rich targets as well. But the effect is really seen with GC-rich targets. Overall, we have tested a wide range of AT and GC rich amplicons and primers, and we can see that it does not have a preference, and it can handle both types of templates, making this a very convenient option also for multiplexing different targets. And this multiplexing is another great feature that this kit has. The kit is well suited for both singleplex and multiplex assays. Multiplexing is often not easy and requires an optimized composition, optimized buffer. And currently there are not a lot of options in the market for multiplexing RT-PCR reactions. As much as I can tell, there is one kit that offers high multiplexing and a few that offer two-plex reactions to include an internal control. But other than that, multiplexing is something that is not easy to optimize the composition for, and there's not a lot on the market. So if you want to get more out of your RT-PCR assay, you can consider multiplexing it and looking at multiple targets at once. Finally, I also talked a bit about the stability. As with all of our products, already mentioned, is that the stability tag is incorporated into these enzymes as well. And on the right, you can see a brief, you can see a demonstration of one example of what we test when we look at the stability. There is a reference kit stored for 1 month at -20 degrees, and the test kit that was stored, the same kit, the same products, but it was stored for 1 month at 25 degrees in an incubator. And then we look at how it performs. And after 1 month at this stressed condition, we do not see any differences in the performance when compared to the reference. So you can safely use it in situations where you can make use of this stability feature. And this also means that you can be you don't have to worry if our products come to you in an envelope without any dry ice. Another interesting benefit our product has is that we have also included a uracil DNA glycosylase in the mix, or UNG. So you can perform, it also has DUTPs in the mixture. So you can perform UNG treatment to remove and prevent carryover contamination, as demonstrated on the right. UNG works by removing uracil nucleotides from double-stranded DNA. So, for example, if normally if you're a diagnostics lab, the sample material coming into your lab will have say if you're analyzing DNA, it will have it's a regular DNA. It won't have any U nucleotides in it. But if you use this technique and you use DUTPs in all of your PCRs, that means all of the lab-produced DNA that you produce, for example, here in the PCRs that can accidentally contaminate your reactions, will be produced using U nucleotides. And that means that you can use this uracil DNA glycosylase that is very highly specific to double-stranded U nucleotide containing DNA to contaminate any of the carryover contamination that happened to be included in the reaction. And this degraded DNA won't be used as a template. Whereas, and it won't target any of the normal DNA that you will have. Another important note is that Salini UNG is a passive component in the mixture. It is highly specific to only this type of DNA, and it won't impact the reaction if you do not use it or if you do not need it. and it will be inactivated and degraded in the first heating steps anyway. So if you do not see the benefit of this feature, there's no issues. You can just skip the UNG treatment step and proceed straight with PCR, RT and PCR. So taking this all together, we can say that SolisFAST one-step RT-PCR kit with UNG offers one of the fastest RT-PCR workflows currently on the market, without compromising in sensitivity of detection, while offering additional benefits such as multiplexing, great performance with G-series targets that is further boosted by AmpliBoost, and of course room temperature stability, and then also the possibility for UNG treatment. So if this solution seems interesting for you, have a look at our website and make sure to reach out to us, either by contacting our website chat, calling us, or emailing us at info@solispyline.com. We are happy to discuss your workflow and advise you to choose the best option, or also advise you on troubleshooting your experiments if you need to. And we also offer free samples. So if you want to try out this product, you can see if you like it as much as we do. So feel free to make use of it. I would like to thank everyone for listening. It was definitely a pleasure for me. And I hope you got some interesting ideas or information as well. Feel free to reach out if you have any questions. And have a nice day.